Hello, everyone. So, as you could see from the first picture, we are going to talk about phishing today, starting with demystifying two-factor authentication, showing you some no-magic techniques about reverse proxying, and then how to hijack the stolen session in a way that you can instrument them and automate some of the post-phishing activities. We will end up with some demos, and we will discuss upcoming challenges. So, how many of you think that two-factor authentication really helps against phishing or anything else, like takeover of your account? Raise your hand if you think that 2FA is useful. Raise more? Okay, good. So, a couple of myths. I don't know if you agree about these points, but in fact, point 1 and point 2 are just like partial mitigations of a problem that you cannot really fix with the ways they are trying to do. Because in fact, 2FA is only minimizing password spraying, for example, like the fact that the attacker if the attacker doesn't know your second factor, but the credentials cannot authenticate. And also the fact that if you receive an unsolicited token, and if you didn't do the authentication action, you might think that something dodgy is going on. But in fact, when you do situations like the reverse proxy scenarios that we will show, the victim believes that she's interacting with the real origin, so this thing is not applicable. And also the point about, in general, that we are more secure. Again, we are just raising the bar. We are not fixing the problems. Actually, there was a nice attempt to fix the problem when universal two-factor was introduced, UB keys and this kind of Titan keys, this kind of strong authentication. But first of all, it's not really implemented. And second of all, Marcus and myself last year, we presented some research in OffensiveCon where we actually bypassed even that which was claimed to be unphishable via a bug in WebUSB, which was actually removed by Google in a measure released and reintroduced with a blacklist. Very, very nice. Since, as we said, any form of authentication that used 2FA, as soon as the token and the second factor authentication is submitted in the same form, so like in the same origin via web, basically with a solution which is a reverse proxy, you can definitely steal everything that you need, not only the initial credentials, but also the token. SMS, push, OTP, Google Authenticator, any kind of time that the token actually needs to be submitted on the same site, basically means that you can proxy in real time and get the session. So, doing, let's say, this in a smart way, you not only you intercept the traffic, you fulfill the request, and so magically the 2FA actions are triggered. But as you will see later in the presentation, we also instrument the session. So we hijack the session, like taking the cookies and passing it to an instrumentation framework in a way that we can automate some of the activities that otherwise you end up doing manually when you do phishing. And yes.
All right. How many of you are familiar with man in the middle? All right. And how many of you are familiar with man in the middle in web applications? All right. So this is clear that there is nothing new in this approach. We are doing, for example, when we do web application testing, we do man in the middle in the browser. In this approach, is slightly different. We are performing man in the middle by just rerouting people to the wrong domain. And let's see some example. So this is something quite old, as I was saying. And back in 2005, the US government was releasing this paper about phishing trends. And they were saying that as related to the phishing, a man-in-the-middle attack involves an attacker serving a proxy between a user and online e-commerce site. Now, it's not only e-commerce, it's every website or any site. So basically, we are in the middle and we are translating requests back and forth. So what changed in these years? Not that much for the first 10 years. Then happens that at Portcullis they released a tool about phishing, which was based on some rules on Apache. And then in 2017, Cuba released Evil GeneX, which was quite the evolution of this approach. So it was intercepting and extracting credentials and cookies. Also in the APTs, we saw some researchers like Citizens Lab and the Amnesty International. So we saw this approach exploited in the wild. And let's see what happens. So basically, how does it work, a reverse proxy in a man-in-the-middle context for the web application? Nothing special. So this is our dashboard. And basically, whenever we receive disappointed. Oh, nice. Whenever we receive a request, the victim that wants to connect to the real website, Bob, actually, in this example, the real website is portal.bob.com, but the phishing website is portal.bob.co. So basically, it's sending the request, and we are patching the request. So in this case, the headers. So we're patching the host, the origin, the referrer, the cookie. Patching means that we are sending the request for the phishing website, simulating the user, the victim. So we're changing all the information from phishing domain to the real domain. Once we send the request to the phishing domain and the real domain replies back, we patch again. So we say, okay, we are not the real domain, but we are the phishing domain. In this way, we don't break any same origin policy, we don't break any security rule, any cookie, anything. Same approach is for the body. We change the body, so anything that matches the phishing domain will be replaced to the original domain, and same back. There are slight modification in the body because, for example, we can find some gzipped content or deflate or whatever. Also, some content type whitelisting. For example, we don't want to replace or manipulate images or binary files, so we can skip this kind of approach. For the implementation, we used Golang, just because it's quite high performance syntax and language. It's quite stable, and they have a good library ecosystem. And also the perfect part is the cross-compilation, because you can imagine that we can compile this tool for a Raspberry Pi or for the washing machine or whatever, and then we can run in any kind of scenario. So whether it can be a red team or it can be a normal phishing engagement, you can deploy the machine in a compromised system or in our own system. It's just around 2,000 lines of code because it's simple enough. The name is, as we said before, Muraena, and here's some feature that we implemented. The first one is the web crawler, which is basically when we perform some HTTP traffic, let's assume in Google, and we want to go to google.com. There is not only google.com. There are many websites behind, many subdomains, many resources. And we want to man in the middle all those resources, because it's not just about Google, but all the other origins. Also, customizable tracking, because if we want to track people coming to our phishing domains, we want to see if person A has authenticated and what are the cookies and when he arrived and from where. Also, static content server. In this way, for example, we can host our malicious application or JavaScript or resources generally. Wildcard domain support, we're going to see in a minute. And the final is the browser instrumentation integration, which is basically we have the cookies, we have web sessions, but what do we do? Do we still go to the real website and enter manually username and password, or can we abuse this information that we just collected to automate this process? So how can we do this stuff? We'll see in a minute. Since we are using Golang, the proxy core is based on the single host reverse proxy, and with some transformer and rules that we provide.
No magic again.
This is something not new, and since it's not new, there are some anti-reverse proxy approaches. So we are going to see some solution that some vendors decided to adopt to prevent anti-reverse proxy solutions. So basically, to debug this approach and to bypass, it was enough to use Chrome Developers Tool, so the JavaScript debugger and the console inside the browser, and maybe Burp proxy, just to see what kind of traffic is working. So let's see the simplest one, something universal in the manipulation. In the HTML and the HTTP, we have this sub-resource integrity, which is a security feature. Basically, they introduced this feature to prevent CDN to manipulate contents and then push back to the client. So in this way, when we decide to use some resources, we compute a hash and then we put inside the element, like this one, and then we name it as integrity attribute. So what happens is that when the resource will be loaded in the browser will compute again the hash of this resource. If this matches, it's fine. Otherwise, it won't execute. So it's a security measure. But again, we are in the middle, so we can simply delete the attribute, and the browser won't compute any kind of calculus. So just this bypasses this security measure by simply deleting the attribute.
This is the basic, grep and replace idea behind most of the stuff that we grep and replace for headers, or as Giuseppe is showing, like attributes of other security features.
Next one, the content security policy. This is the same. Basically, in the content security policy, we instruct the browser to act properly and to not execute malicious resources. But there are some points in the HTML that we can manipulate. For example, the nonce that can become no more nonce, for example, so the browser won't know. Or also the meta attribute, which is the content of the security policies. You see here, it's commented. And then you can just delete this. And in a similar way, we can remove the content security policy headers. So in this way, we can inject other resources, so we can act badly as we wish. So these are more the generic one. Now let's see something about real vendors. So for example, GitHub. In GitHub, they decided to use this approach. There is a meta attribute called GAS proxy site detection payload. And this payload is a basic C4 encoded, and as you can see here in the console, is translated with some random string, remote address, which is the client, the request identifier, the timestamp, and the host, github.com. So what happens is that when you run the application, just using the debugger, you can see that there is some JavaScript that is loading this selector just with query selector, and then checking if it's an instance of the HTML element as well as another selector, expected hostname. Then it makes some operation. And then if the domains are different, because, for example, we are running GitHub from a different domain, then this will fail and there will be an exception. Basically, the bypass is quite trivial because this condition needs just a false statement just to not be executed. So, for example, we can just translate this JS proxy site detection payload to nothing or something else, expected hostname to nothing or something else, and then you bypass this measure, for example, in GitHub. Dropbox. Dropbox is nice because Actually, I don't think this was intentional, but they have this reCAPTCHA in the login or in anything. And by nature, the reCAPTCHA approach, if you run, for example, Dropbox for a phishing domain, you will see that the site owner invalid domain key. So basically, you cannot send any form because it's to prevent a cross-site request forgery attacks. So if you inspect this is masked. So if you go in the DOM and just enable the hidden divs, then you will see that the error is saying that the domain for the site key, and then it pushes the domain, which is the phishing domain. So basically, we are sending the phishing domain to Google saying that we are Dropbox. So there is something wrong because the key, of course, doesn't match. So, and we identified the request, this is basically Google. So basically Dropbox is saying to Google, hey, send me something for this key and this value that decoded is the phishing domain. So basically, by the reCAPTCHA protocol of this nature, when we load the page, then there is a request for the image or the token to the Google. But since the domain is wrong, this request is failing, and then we cannot proceed anymore. So what can we do is basically translate in this way. Just if we go back, this domain is the phishing. So we just changed this domain to Dropbox, and basically we decoded this value from base64. We changed the domain to Dropbox and then encoded again, and basically we bypassed the reCAPTCHA in approach. So basically this is a feature of the proxy where you can enable the base64 translation. So other than normal patterns, just if you find A, translate with B, you can also say if you find something that is base64, then just decode, and if there is any pattern of the one that we defined before, just translate it and encode again. And then you can also use some padding. In this case, it's interesting because usually base64 padding is the equal. But if you notice here, there is a dot in the end because the request is sent through the URL. So instead of encoding the dot, the equal, they just decided to use the dot. So there is this kind of flexibility. Next one, Google. And yeah, the sentence is quite common. If it works for Google, works for all. Basically, I'm quite sorry to say this, but we
How many people from Google in the audience? Raise your hand.
No, they are somewhere else.
There are some for sure. But
thank you, guys.
They are shy.
No, basically, we test for Google because Google is so complex. So if it works for Google, it works for everybody. And this is something of the changes that we implemented to make it work in Google. So, for example, as you can see, it's full of regexes in Google. So the idea is just to patch the regex to match it in the phishing side. So this is something that can be automated, but not that much. So, for example, this regex is just a Boolean regex where we just inject our malicious domain. So if, for example, our malicious domain is based on .com, we don't need this subdomain. Same for here, and same for other rules in base64. So basically, this approach works also for Google. So even Google is not protecting this approach. Now let's see how to use this session.
Yeah, so we will see a bunch of videos soon, so you will understand even more in case there are some things that are not clear, but again, this is no magic. So the thing is the following. Once we capture the credentials with Muraena, and we are also collecting the token value, we actually don't need the token value because we hijack the cookies, right? So the point is, when you are hijacking the cookies and you are actually instrumenting them, not manually but programmatically, where do you need to go through to reach the original target? Because usually the thing is, let's say that you have a VPS where you are running Google CDN.co on a public IP. You are running Muraena over there, and you have X users where you already have cookies. So you can actually instrument in Docker instances that go through the same reverse proxy IP in a way that there will be no behavioral change rather than the original login on the phishing origin. in a way that you can then keep indefinitely the session live, in theory, until they detect you. So, in general, this is how what we discussed so far. So, the red part are the things that we modify, either in the request or in the response. So, 2FA. Now, when we collect the cookies, we have like this Docker container server, or a bunch of them, where you have a lot of RAM and the ability to run a lot of Dockers. In each Docker, there is a Chrome headless, Chrome headless that we instrument via the remote debugging protocol stuff, and where we keep alive all the sessions. So the nice part here is that there is no magic also in this Necro browser part, because we wrap around a nice Golang library which is called Chrome DP, and which already use the Chrome DevTools protocol, which is a great feature of Chrome. You can spawn as many Dockers as you can, and in this way you can basically keep as many live sessions compartmentalized in different Chrome headless. Now, how to use this is up to your imagination, because you are hijacking the user session, so it depends what you want to do with that. Everything can be automated. In the demos, we're going to see just some of the examples that we were playing with, but imagine that you can use the idea of running instrumented browser to do much more than just post-phishing. You can do OSINT, you can do other types of instrumentation. And in fact, what is really interesting is this cat and mouse game between who is trying to detect access to websites via instrumented browsers, or like non-human driven browsers, and people that instead are fighting like us, the opposite side, so making a headless browser always winning, right? So there are a nice bunch of nice resources that you can check out, specifically the Intoli site, where they speak a lot about what properties you should emulate, or what people are trying to detect to see if you are an instrumented browser. And the latest research basically proves that it's very difficult to detect if there is a human or not behind the browser, basically. So, as we were saying, examples could be really endless. Like, since you are, again, hijacking the user session, you might want to dump emails, you might want to add application keys, you might want to download all the files, things like that, screenshots, all the things, dump HTML. It's up to your imagination. So, we are going to show you a couple of videos in a way that you have a better understanding of what we discussed so far. So the first example is Google is the target. We are serving the phishing domain on phishing.anti. And as you can see, Muraena is reverse proxying live from Google. The victim is landing on the login page, entering the credential, as if everything is intercepted in real time, and also of course, since it's a reverse proxy, the content is fetched in real time, and in this case localized to any kind of language the user choose, which was English in this case. Now, 2FA with SMS. The user, as you can see, gets the, as you can see on the top right, gets the SMS, enters it, and then in a second Gmail will be loaded. It's a bit verbose, like if you reverse proxy Gmail, they made a lot of requests. And then nothing. I mean, from this point, we already configured that we want to instrument this session. And so this is actually a new Chrome instance on the real origin with a cookies set, which is actually looping a bunch of actions like taking screenshots after searching for keywords over your email box. Of course, the same could be implemented like search for password and dump all the emails, not just taking screenshots. But again, this is just an example. And then going to Drive and potentially downloading other stuff. And in fact, we are going to show, yes, some of the downloaded screenshots that are dumped automatically by the tool while you say, go to this page, search and screenshot, or alternatively.
Just one thing here is that on the left here we can see that there is the proxy running, and on the right is the Necro browser, which is the instrumenter tool. And you can configure the tool and the proxy to work together in a way that when the victim reaches a specific endpoint, so for example, after you are authenticated and then you go to / let's say home, then you send a request to Necro browser, which is the instrumenter, to perform all the automation. So you can say, okay, we are sure that the session is valid and the cookies are valid, and we reach at that specific endpoint. Now you can automate the next step. So
yes. This is actually, I mean, the whole idea is useful because even if you do a lot of OSINT because you phish your targets, you might end up with targets that click and give you credentials or, sessions, and you don't know exactly what kind of privilege they have. So what you want to do is actually a post-phishing automation to automatically check, if the guy is a sysadmin, and then you automatically know that you might have access to Confluence, and then you might you might want to search for, network diagrams that people upload in wikis, in Confluence and stuff like that, rather than pivoting in a network. So you might end up doing red teaming or whatever simulation in a different way.
And another thing is that, for example, in Google, we are using Google, but there are some paths in Google where you can improve the security, and then, for example, you can change password, or you can add password for the application. And basically, that specific path sometimes are protected by a password, so you need a password to do this. But we already know the password. We're just not using username and password again. So we just need to instrument the browser to say that whenever we see again the login password, we just send again the password, and then we are authenticated, and that's still valid. But in this way, for example, you can perform some kind of persistence inside Google, because you just create a password for an application, and then even if the victim realizes that they are vulnerable, or they've been hacked, and they change the normal password, the application's password is still there. So
exactly. We are going to show you, in fact, another example. The window, I see. This one, this time is in Google.
Gmail, GitHub.
GitHub again. So, as you can see from this tab that I quickly closed in Firefox, I mean, this is the original account of our victim. Just want to prove that we don't have any SSH keys added to the account that we are going to phish. We are not showing you all the initial part of the phishing because, I mean, everyone does it in a different way, and we want to focus on this specific scenario. So, once again, the victim landed on GitHub. She's browsing just to check if everything looks fine and the reverse proxy works fine. And basically, as soon as she decides to log in, once again, I mean, any type of 2FA that is not universal two-factor is applicable here, not just SMS. So we collected we harvested the credentials. You can ignore the new victim thing because it was an old video where we had the small bug in our software, but it's expected. So 2FA. In this case, we configured that the hijacking of the hijacking of the session will happen when the victim goes to settings profile. Okay, so you will see this. So we start actually the Necro browser part, which is again this RESTful API that waits and then spawns Docker to hijack the cookies for you. So the guy's gone to the profile, and basically the tool goes on the SSH page, adds typing the new SSH key, waits a few seconds, add the SSH key, and basically in this way you can automatically backdoor with a new SSH key every people that is getting phished on your GitHub page. And then you can have another script that auto-pull all the code or whatever, up to your imagination basically. But an idea that quickly allows you to do actions that then basically persist, even if an administrator is smart enough to understand that something dodgy is going on. And so maybe half an hour after you have credentials, everything doesn't work anymore, but maybe they didn't see the password you added in GitHub, and so you can keep pawning.
Just one thing.
Yes.
Is about the headless. As you can see here,
True. Sí.
A new Windows spin up, but this is just for the demonstration. But in a headless browser, you can avoid this and just run in background without opening any windows. But this is just for the proof of concept. Otherwise, you won't see anything.
Exactly.
So you can run the Chrome instrumented in a headless mode without any screen, or you can show what's happening.
Now, to mention another few examples that we are not going to release as automated when we release the code the 14th of May, so soon. But still, I mean, imagine that you get a Gmail account, and then you have something like this that basically goes through all the contacts of the guy, and then basically automatically does user impersonation, sending from that account malware to his contacts. So these are all things that you can easily automate with Necro browser, for example, or any browser instrumentation. So, upcoming challenges. I mean, we saw this nice bold statement from Google, better protection against man-in-the-middle phishing attacks. So we'll see if this is going to be implemented when, and if this is going to make our life as attackers in offensive security scenarios more difficult. Probably, but we'll see. So future work?
Yeah. So for the future, which means after the release, we are planning to integrate this tool inside Bettercup. How many of you are familiar with Bettercup? Oh, nice to see. Yes, because we consider Bettercup super powerful and quite important for this community, and it's de facto man-in-the-middle tool. And this is a man-in-the-middle tool, so we are planning to, with Simone, to integrate this inside Bettercup and then have another module for the phishing campaign. And then you can imagine when you are performing man-in-the-middle, maybe inside an organization or something like that, where you just poison the routers or the DNS and then redirect to the phishing domain, and then you can perform all the magic even inside the networks. For the browser automation, yes, support some other web portals, but actually it's not our main goal to support all these portals. So whenever we release the code, we won't create configuration just to pawn this and that website. It's just the tool. Also some instrumentation jobs and queuing, so just to use imagine in a phishing campaign with thousands of victims, then you need to be able to scale whenever, 100 or 1,000 people are coming. So for now, I think we are able to handle 100 people just because we didn't test with a lot of resources. So this is a part of our plans. And yes, and use also the browser instrumentation for the recon, the open source intelligence pre-phishing part. So we can scrape the company XYZ, for example, on LinkedIn. We just provide the name of the company, and then you just collect all the victims, and then you can do a lot of this operation automated. So basically the goal is, we are lazy, we want to automate this stuff and just focus on the real phishing part, which is collect the information and make something logical. Yes, this is where you can find our code in a couple of weeks. Or no, even less, just 4 days. 4 days.
14th of May.
It's not a phishing link, so you can just scan the QR code. Trust us.
And in case, the thing is the following: when everything is going to be published, I'm sure that none of you will do it, but since this is going to be recorded, other people will see it. Don't ask us to configure phishing templates for your own nasty phishing campaigns. We don't do that. So just ask technical questions, and yes, don't cut this part as well.
Yeah.
That's it. Thank you.
Amazing. Amazing talk, guys. Thank you so much. Thanks for all the fish. Do we have any questions in the room? Here we have one in the front. Just get the mic.
So thanks, guys. And my question was, since with the more serious vendors, it looks like a cat and mouse game, and everything they came up with are just client-side solutions in a JavaScript that you can patch anytime. Do you see any vendors doing any serious step in like protections that can actually work and not relying on security through obscurity, basically, on JavaScript, which is even dumber?
There are, Giuseppe will probably say something different, but what I've seen sometimes, and we still didn't look into it, is JavaScript that does like drag and drop challenges.
Oh, okay.
Which you can also kind of automate, but it's start to get a bit more painful. But apart from that,
actually, I was saying before, Google was our kind of reference in this context. And what I found challenging with Google was that the JavaScript that they use is dynamic. So sometimes the domains and the subdomain are concatenated and you cannot predict. So you need a lot of debugging, and then you can just, it's quite tricky, but it's not impossible. You just need time to perform this operation.
Then if someone implements polymorphic, obfuscated JavaScript that changes even dynamically while
but eventually you live in the browser yourself, so you have access
eventually, exactly.
You can always debug this. Also, for example, Google, just to avoid this kind of instrumentation, they have the elements in the DOM with the identifier that are random, so they are dynamic. But still, this doesn't fix the problem, because you can just say, take the first element of the DOM, and then the next, and the next, because they are nested, so you cannot say, okay, take the ID or the class. You can always find a way to bypass this. So I don't see this as the real solution. This is just to stop, let's say, script key this from this. But if you are motivated, then it doesn't work.
Can I have to? So another question related to this one. And do you see instead the major vendors influencing the development of the Chrome headless project itself and all the debugging protocol in a way that can be more easily fingerprinted by them?
I didn't notice this, to be honest.
That's cool.
No, not yet. Not yet.
Not yet, actually.
Hi, thank you for the talk. I have basically two questions here from a defense perspective. Obviously, there's defense on the website side. Is there anything at the protocol level like HSTS or public key pinning that could prevent something or disrupt reverse proxies? And the other thing is defenses on the client side, which would probably take the form of like a browser extension. I know that Google had a browser extension at some point they released that makes sure you always inputted the password on the Google website and not some other website. So.
Actually, this is the cat and mouse game. So the problem with the extension, this stuff, is that you can always bypass these approaches. And I think that we are lacking of some kind of standards in this. And I think it will take some years, in my opinion. And
the first question is basically doesn't make any difference because you are in the middle. The pinning doesn't make any difference because you are actually connecting to an origin that you didn't pin because I registered it, and HSTS I can strip it. The Chrome extension could work, but it's up
you can do that for every website, I guess. You can cover it for it.
That's the problem. Maybe for the internal networks, if you have the certificates installed in your browser, and then, but the problem is that one of the success of these reverse proxies is that Let's Encrypt, for example, open the possibility to register SSL certificates for free.
Even wildcard.
Even wildcard. That's why we are succeeding. We are starting to release this tool, and that's why this is something quite old that nobody were using before. Because if you want a wildcard certificate, it's quite costly. So it was, or it is sometime. So
a wildcard certificate used to cost up to, let's say, 1,000 euros if you could find a cheap one. and including the VPS cost that was more expensive back then. Now the cost to do phishing is like $10, $15.
So you can imagine that you must be really motivated to buy a certificate, and so we don't exclude that this happened in the past. But now that the certificates are almost free, everybody can do this. That's why we need to raise the bar again.
So your advice for website owners and users is switch to hardware tokens like UTF, use USB-based keys and hardware tokens. Those would be much harder to...
Yes, where there is some kind of crypto challenge with the origin, and there is actually some kind of origin enforcement, which is not, relying on the other nights, that thing that the U2F, as we said, there were still some bugs, and that it's not... they might be reintroduced in the future in Web USB, you never know, but U2F currently is a great way to protect against this.
Amazing. Any other question? No?
Thank you.
Okay, thank you.
Thank you.
Let's give a warm